half-life comes down to of 238 to 80 years. We can treat this plutonium-238 after chemical separation. The process of separation is well known. So we can treat plutonium-238 through the same nuclear reaction, producing plutonium-237, which is a half-life of 40 days. Then it will go, totally plutonium can be eliminated. It will go into another radioactive elements in the uranium class. Now, uranium, of course, exists in nature. If you do not want this uranium, what you can do, well, go on treating the same way and through nuclear reaction until it reaches the stable form of lead. Lead is the heaviest element known in nature, and there is stable form of lead. You can do this. I believe this is entirely feasible, and the machinery needed exists. Chemical separation for the process needed exists. I don't see what they lose by trying this process.
The Roy process, says its inventor, will change unstable beta radiation-emitting cesium-137 with a half-life of 30 years to cesium-136 with a half-life of only a few weeks, strontium-90 with a 28-year half-life to strontium-89 with a 50-day half-life, and plutonium-239 with a half-life of 24,000 years to plutonium-238 with a half-life of 89 years. And then treated again with the Roy process, it becomes plutonium-237 with a half-life of 45 days. And what's more, this theoretical innovator in nuclear physics tells us the hardware exists and the chemical extraction processes are well known. And he doesn't see what they will lose by trying his process.
And put it in a crowded restaurant, within a period of 15 or 20 minutes, half of the people would have received lethal doses.
Surely he's talking about a terror attack. No, he's not. He's talking about the huge amounts of radioactive waste the U.S. is still trying to get rid of more than a half century after we exploded our first atomic bomb. But we are awash in the poisonous stew that was churned out when we were making them, tens of millions of gallons of highly radioactive liquid waste. 8 years ago, when we reported on the Energy Department's effort to clean it up, we found a slew of projects years behind schedule and billions over budget. However, officials insisted that they had learned from their mistakes and were about to get things under control. Well, hey, we went back to find out. How are we doing?
Basically, I would describe it as an abysmal failure.
From 1993 to 99, Bob Alvarez was the Secretary of Energy's senior advisor on cleaning up the nuclear waste.
If you were to take a cup of that waste and put it in a crowded restaurant, within a period of 15 or 20 minutes, half of the people would have received lethal doses. That's how dangerous this material is.
The material, the radioactive waste, is stored in old and failing underground tanks. Some of it has already seeped into the ground. The largest and most contaminated site in the world outside of Russia is here at Hanford in Washington State, right on the Columbia River. It's the home of the Manhattan Project, where they made the plutonium for hundreds of nuclear bombs, including the one they dropped on Nagasaki. Today, it has 53 million gallons of high-level radioactive waste, and many of the underground tanks here have sprung leaks.
Those tanks are about 50 years old, at about 500,000 gallons in capacity.
Harry Boston is the Energy Department official in charge of maintaining Hanford's 177 underground tanks. And all around here are tanks under...
All around in front of us are 1 million gallon tanks below ground containing waste.
How many of the tanks have leaked?
67 are known or suspected to have leaked in the past. None are leaking today.
67 though?
Yes, that's our number.
But Dr. Boston, is it a crisis? What are the words you use to say 67 tanks with the worst kinds of chemicals have leaked?
Well, first let me say it's absolutely not a crisis. It's not a crisis because we are safely maintaining the waste. It's very urgent, however, that we get on with this cleanup.
That's because radioactive waste has already contaminated a large pool of groundwater migrating toward the Columbia River, a major source of irrigation and drinking water in the Pacific Northwest.
There's 100 square miles of contaminated groundwater, and a lot of work is underway right now to hold that groundwater in place, to treat it, and to ensure that people are protected and don't have access to it.
But wait, but you are saying there's 100 square miles of contaminated groundwater under here.
That's true.
That's enormous. This is not groundwater anybody's ever going to drink, obviously.
That's absolutely correct.
Another of his problems is the volatility of the waste in the old rickety tanks. Until last year, the radioactive soup in this million-gallon tank, which the Energy Department videotaped, got so hot it rose uncontrollably toward the top. Until engineers got the belching bomb waste under control, there was a real fear it would explode. Harry Boston says they're working hard to fix the tanks before there's a catastrophe. Now, wouldn't someone have said that to us 8 years ago?
I would think so.
And it's been 8 years. I mean...
Well, for the last 8 years, for the last 10 years, there have been commitments to do this work, and we're coming through on those commitments now.
Behind schedule?
Behind the initial schedules on our current schedules.
The plan was, and still is, to convert the most highly radioactive waste into leak-proof glass logs that will then be buried in stainless steel canisters like these. It was originally budgeted as a $4 billion project and was supposed to have started in 1999. Now it's a $50 billion project that won't produce any glass logs till 2007. Yet Harry Boston remains unfazed.
Well, I've got a good team and a good plan and tremendous public support.
That's just the kind of assurance and optimism we heard 8 years ago when we visited another Energy Department nuclear facility, the Savannah River site in South Carolina. They were just beginning to construct a glass logs facility, which opened with considerable fanfare a few years later.
We know how to make this thing work.
Well, not exactly. In addition to being years behind schedule and billions over budget, the facility has been plagued by engineering problems, among them this white elephant. It was designed to be a pre-treatment facility, pre-treat the waste before it goes into logs. It was supposed to take... I'm standing on the most contaminated piece of real estate. It wound up taking 13 years and $500 million. And when it was finished, it created more problems than it solved. It produced a large amount of data in 2001, told us about how they had rushed ahead with construction of this. Of the General Accounting Office, Congress's investigative arm, says her agency issued warnings years before the construction of the facility was finished.
Well, in 1992, GAO said, you've got a problem, you need to look at other technologies. In 1993, a DOE technical review